Hello, welcome back. Come back in. Take a seat. Hope you had a good break, managed to get some refreshments. We are, as promised, recommencing here on the main stage. But I do want to remind you that there is a workshop about, it's called the EU Artificial Intelligence Act and Standards, Your Pathway to the European Market. That's being run by the British Standards Institution, and it's starting right now in track 3. But here on the main stage, we're going to continue to a headliner. We have got Larry Heck, who is Professor of ECE and Interactive Computing and Executive Director of the AI Hub and Machine Learning Center at Georgia Tech. And he's going to be speaking on the subject of revolutionizing innovation at the speed of thought. A bit of background on Larry. From 2017 to 2021, he was the CEO of Viv Labs and SVP at Samsung, where he led Bixby for North America. And prior to that, he was a principal scientist at Google, leading an advanced dialogue effort at Google Research. We're extremely delighted and lucky to have him here with us today, so please give a huge warm welcome to Larry Heck.
Good morning. It's good to be back in Montreal. It's been since 2019 for me. I actually have a long history with Montreal. Warms my heart. Back in '99, I helped start the Nuance Montreal lab. So there was a lot of speech recognition activity, even back 25 years ago here in Montreal, a machine learning activity at that time. And even before that, because many of the people that we hired into Nuance in '99 were from Nortel. So Montreal has a long history, although at that time in '99, we made front page. We were just a little startup. We made front page highlight in the newspaper here because, and I think the article said something like, high technology is coming to Montreal. And now you look at Montreal and it's just amazing what's happened in the last 25 years. So very, very happy to be here. The title of my talk is Revolutionizing Innovation at the Speed of Thought. So let me tell you a little bit about what I mean by that. And by the way, I'm now a professor. I've been a professor for 2 years. So I'm going to give more of a professorial talk. But I spent 30 years in industry. When I started the speech group in Nuance, Montreal, I was head of R&D at Nuance. And then I started another lab in Montreal, which I was a chief scientist of speech products at Microsoft. And then, and even before that, I was at Yahoo, and I started another lab, Yahoo Montreal, at that time. But what I'm going to talk about today is sort of combining all of that together, along with what I've been doing the last 15 years in NLP, and then especially the last 2 years as a professor, which is putting in front of my lab a grand challenge, which is, although we've been working on this problem of language models for a long time, we now are at a level that we have an opportunity, in fact, I think a responsibility, to push the technology to the next level. And I think that certainly is going to involve some interfaces that are better than typing to a chatbot. Right? So how are we going to open up this connection between humans and AI so that we can go faster and faster, sort of thinking about augmenting humans, enhancing humans, not replacing humans. So the idea is to build a virtual assistant to give humans superpowers. So these are superpowers in whatever area of interest that you have. Usually it's going to be an area that you have some level of expertise, but you want to enhance your ability with the AI. So you want to actually leverage something in the AI that you don't know about as much. So thinking about that and motivation for this title, actually for the talk, I was remembering a book that Bill Gates put out also in '99, Business at the Speed of Thought. And the idea I think that Bill had at that time was the role of technology was to speed up the process of when he had a thought as CEO of Microsoft and wanted it executed through the company, the technology should make that faster and faster, right? So that we start thinking about innovating the company rather than having to spend years to actually do the implementation. The technology should make it just happen. So I've been jamming on that theme as a professor and organizing my lab around this kind of idea. So naturally, as you might imagine, as a professor, what we do at universities is research. So thinking about how would we take an AI and make it available for me as a researcher, but also my PhD students as researchers, to give them superpowers, to give me superpowers. So that we are doing the research as humans, but there are certain tasks and certain activities that we have to do as researchers that just take a lot of time. And so can we leverage the innovations in AI technology to speed that up? For example, reading scientific papers. Now, I actually work in natural language processing in this area, which is where the large language models came out of. So as you might imagine, it's a very fast-paced research field. Papers being published every week in the archives. Very hard to keep up with what is going on in the research community. And so having a research assistant that operates at the speed of thought would be highly valuable to us to help do our research better. And of course, staying on the theme of university, also a teaching assistant at the speed of thought. So grading papers, but also providing tutoring to students to help them with learning concepts. Leaving the university, let's say in law, legal research at the speed of thought. So this would be used by a person that's not necessarily an AI expert at all, or medical research at the speed of thought, doctor's assistant. And then even as we go out to the creative arts, composer's assistant at the speed of thought. I'm a musician, but I haven't had the kind of music theory I would need to be a really good composer. So I have many ideas, musical ideas. I've always wanted to be able to translate that over into compositions. So in fact, in this area, along with teaching and research, these are the three active areas from my lab that we're working on: a research assistant, teaching assistant, and creative assistant for composers, a composer's assistant. And then extending that to an artist's assistant or a writer's assistant. So you see the theme that I'm saying here, which is our goal is not to automate, our goal is to augment. Now, I had the lab focused on two key areas that I think are really important to make this innovation at the speed of thought a reality. The first is so-called situated. Situated, think about that as leveraging everything that you know about the situation at that time for the AI. So the AI understands, let's say you're reading a scientific paper, it reads a scientific paper also and knows what you're looking at. If you're looking at a web page, that sort of thing. So right place, right time, leveraging context. So situated is really important. And the second is neurosymbolic. So decomposing complex tasks and offloading some of those tasks from the large language model to downstream tools, right tool for the right job. So I'll talk mostly about the situated, and I'll mention a little bit about what we're doing in neurosymbolic. But the key is, and the point I want you to take away from this talk is, if we really want to achieve innovation at the speed of thought, it's going to require ongoing advancements in situated and neurosymbolic AI. We're not quite there yet. So let me talk a little bit about that. So in the lab, I've organized our research into these broad areas. This is the situated AI effort. So there's conversational content, as I mentioned before, papers, web pages, that sort of thing, where the AI and the human are both reading the same literature. Conversational vision is kind of obvious. Smart Glass, I think, was a little ahead of its time when I went to Google. That was at the tail end of Google Glass. I think that's going to be a very compelling application going forward, where the AI sees what you see as you're walking out in the world. And then conversational expression. This is something that's not as commonly discussed, and it's actually a relatively new area of research, at least from the NLP community, into it, which is, like I said, rather than communicating to the AI by typing, why not use all of the modalities that humans have evolved to use? Hand expressions, body language, facial expressions, of course, voice. So conversational expression is how do we actually teach the AI to not only be able to communicate with body language, but also be able to interpret body language. So in each of these areas, there's different research problems that need to be solved. I won't go through the details on conversational vision and expression, but let me talk a little bit about conversational content in a bit. But before I get to that, I talked about situated AI. I'm going to just mention a little bit about neurosymbolic. You may have heard of neurosymbolic. The idea is that the large language model is not necessarily good for all tasks. Like, for example, calculations, mathematical calculations, reasoning, that sort of thing. Essentially, the model is learning what it has seen before, and it has a very good ability to understand what you're asking. So it's a semantic matcher. It semantically understands what you asked for, but then looks through its weights to say, okay, have I seen this before? So if you ask large language models, which is just the single monolithic large language model, some mathematical computation that has compositional, like a function that has many it'll have difficulties solving these kinds of problems. And so rather than trying to sort of force fit that kind of computations inside a single model, neurosymbolic approaches embrace this idea that we'll use the large language model on the front side, but then we'll use tools or downstream specialized APIs to solve some of the more compositional tasks, like I said, or mathematical tasks or reasoning tasks. So this gives us, it's sort of a back to the future, because in the many years that I've been deploying AI systems, we always, every single time, had a hybrid system. We'd have a machine learning system, and then we'd have override rules or override heuristics, and sometimes we'd use specialized tools. So this is not a surprise to me. This is the same kind of thing that we've been doing for years and years. And I've already mentioned this about large language models as not being reasoners. This is still being debated within even my community in the research side, but I feel pretty strongly that that's true. By the way, this is also called augmented language models. Okay, so I'm not going to go through this because I want to save my time more for the situated AI, but we've published some papers, and there's some articles that you can look at to see what we've been doing. Okay, so if we go back to this idea of the AI research assistant, specifically in research, let me step through a little bit of what we do as research scientists, what the process is, and then I want to allude to some ways that our AI virtual assistant can help us. So the first thing, if you're doing research, is the scientist will define that research challenge and then invite your AI virtual assistant, or AVA, to assist. Okay, so the scientist and AVA each study the possible research directions by reading papers, maybe talking to other humans, other AVAs. Then they get back together and they brainstorm. And they're posing questions to each other, maybe even proposing solutions to that challenge. Now, if any of you have done any kind of science work, you know that that's going to involve coding, that's going to involve running experiments. You also know that when you do the experiments and you analyze them, it never works the first time or the second time. You have to keep iterating on this process, this loop of, let's try this, let's have this idea. So speeding that up, that loop of have an idea, have a paper or papers that we're going to pull code from, we're going to stitch these together, run the experiment. If we can speed that loop up, then that's going to significantly enhance the scientists' research. And then eventually find something that works out to be a solution. The scientist writes the initial draft of the paper and asks Ava to help with it. Okay, so for my lab, the team is highly motivated to do this, because if you think about it, right, what I'm trying to do is use the AI to help us to do a better and faster job of coming up with the next big innovation in AI, right? It's specifically in the AI virtual assistant. I tell my PhD students, imagine being able to ask Ava, hey, I've got an idea. Has anybody published this before? PhD students, oh, that's exactly what I want. Okay, so let me dig a little bit deeper into how we would actually do this, and I'm going to talk about conversational content, specifically on research papers. So papers, if you look at a scientific paper and you want the AI to understand that, papers typically consist of a bunch of text, tables, figures, and equations. So let's talk about tables. So here's just a Wikipedia page about wedding anniversaries. If you look it up, you'll see that there's tables on that page. In this case, it's a table about traditional anniversary gifts. And so that the AI needs to be able to read the title and understand it, the introduction, and section titles, section introduction, and of course the table itself. And when I say understand it, I mean without any training. So it ought to be able to go out and read the page, understand the table even semantically so that you can start asking questions. So at UCSB, they put together a really nice data set to get this started. This was just 2022. And what they did was they took tables that were out on Wikipedia and they built conversations over those tables. But a hallmark of this task was you couldn't answer the question based on what was on the table. Like in the very last question here of this conversation, the person's been talking about different state funerals in Canada, and at the end they say, okay, I understand. Could you please tell me the year of birth for this man? Now, what they're referring to is Alexander McKenzie, and his birth date is actually not on there. So the task is situated by the table, but it has to be smart enough to be able to go out and search other information to answer the question. This is a particularly hard data set. It's actually also particularly realistic if you think about it, right? It's not that if you're reading a scientific paper, all the information that you need is going to be on the table, but you want it to constrain. So they were getting 12.4% accuracy, basically, on this baseline. So this is a lot of headroom, right? 100% is the best. So we've done a lot of work in that area. The first paper we did was called Conversational Tables. We started at about 50%. Now we're in the 60s and 70s, and we've been extending that. Okay, so let me tell you a little bit more about the work that we've done and work we're doing right now. So we had conversational tables. We also wanted the ability to generate tables, G-tables, and then just interact with tables. But I mentioned the other two elements of a scientific paper, figures and equations. So we call them conversational figures, conversational equations. We want to do the same kind of thing we're doing with tables. So conversational figures. Now, remember, this is a scientist, in this case an AI scientist, that's reading a very technical paper. We don't just want a summary like you would get sort of out of the box with the current large language models. Instead, we want to be able to answer questions like, in this case, if you look in the far right, the question is, in figure 9, could the authors clarify what the cross at the center of the image indicates, which is this figure below? And then the answer is, well, in figure 9, the cross at the center of the image represents the input values of the parameters used in the simulation. Okay, so that kind of information is very difficult to gather if it's just at a high level. But in this case, what we did was we used scientific open review. These are reviews by scientists of other scientists' papers, and then we scraped all that data and brought it together. So we did the same thing for conversational equations. Okay, so we did a lot of work in this area, and I'm putting up publications, but I just want to just summarize what I'm trying to say here and what the points I want you to go away with. That the idea is we're in a point of time where we absolutely need to embrace AI technology, but I think there's also the fear that AI will take jobs away and automate. And I think the way to do that, to mitigate that, is to figure out ways to augment humans with AI. So a virtual assistant that gives you this kind of specialist capabilities, and I mentioned situated and neurosymbolic. And the key message here is that if we're going to do this and achieve this, it requires ongoing advancements in especially situated and neurosymbolic AI. Thank you.
Thank you so much, Larry. I think we have time for one very brief question. And gentlemen over here, you were extremely quick off the mark. So definitely you. If you could just keep your hand raised, and thank you very much. A microphone is making its way to you. If you could stand up when you ask the question, and if you want to, say who you are and where you come from. And yeah, if you could ask just a brief question. We are a little tight on time.
Hey, Larry. My name's Carlos. Thank you so much for the presentation. Just a quick question for you. When you're going about, if you could go back to your first day in front of your team when you initially, I guess, started creating these three virtual assistants. What are some key learnings and really insights that you could bring if you could go back with all that you know today, back to that first day?
Yeah.
Really from the perspective of someone looking and actively creating these assistants for very specific roles in a very, very large enterprise.
Right. That's a good question. So I guess what I would do if I was going back to the very first day of creating Ava is to remember that there was a lot of work that was done before 2 years ago in the field. And for example, I started the Cortana effort at Microsoft, and Cortana, Alexa, Siri, there are a lot of things that we're going to need to relearn as a community to give the kind of a level of accuracy that the current large language models have. And so that's the first thing, is learn from the past. Don't forget it. There's a lot of relevance there. The second thing, I think, is just focusing on getting the systems, the components, gathered together as quickly as possible, which these days, even in the research community, the code's available. And so it's a wonderful time to go really quickly to assemble together the latest, greatest system and snap it together. It takes very little time to actually do that compared to what it used to be.
Thank you very much. And hopefully, Larry, if people are around, maybe they could grab you and ask you a question offline. But please give a huge round of applause to Larry Heck. Thank you very much.
Thanks.